So precast is only good if you really reach the quality, and this with respect to the design, with the production, and also with the assembly of the elements. And I'm happy to have Dean Frank as a speaker here. Dean was for many, many years quality director of the PCI, Precast Pre-Stressed Concrete Institute in the USA. He's now self-employed as an engineer, has lots of experience of precast plants all over the world, construction sites. And Dean, the floor is yours. Thank you for coming.
Thank you, Holger. And thank you for being kind enough to stick around for the last few sessions. And I have to say, the best sessions on quality and sustainability, right? Everybody's favorite topic. So as Holger mentioned, my name is Dean Frank. I have had the privilege of being in the quality area of the precast concrete industry for the best part of 20 years. I have audited plants. I have been the director of technical programs at the National Precast Concrete Association, where we grew our plant certification program from 70 plants to over 300 participating. And then I spent over 10 years at PCI, heavily involved with their plant certification program, erector certification program, and the personnel certification program. So I've seen many different facets of the quality area, and I hope today that you'll learn a few things and take some messages home with you about quality, our favorite topic. So we'll talk about today the quality assurance of the design of precast, the production of precast, and then the final assembly. And each one plays a critically important role in the success of a project and the longevity of a precast concrete project. So all of us here in this room, we're all stakeholders in the concrete industry, the precast concrete industry, and we're involved in construction, and we all know that construction can be difficult. Many of you may have had days like this. We also can think of examples where expectations were not met, whether it's on the job site, such as this example. Clearly this staircase is not meeting someone's expectations, I hope. This is, obviously there's options here, so maybe there's too many options, but certainly probably not up to the expectations. And then of course this example, I don't know if this is real or not, but we do know that there are problems that take place in the construction industry and real consequences. And so we're going to talk about what we want to happen with respect to our projects. We talk about our first priority, safety, and that goes along the same lines of Professor Pempinen's explanation of producing a safe project for seismic events. We also want that project to be safe during construction and also during the lifetime of that project. We also want that project to be designed and built built as designed and expected. Of course, our architect friends and engineering friends all want that as well. On time, definitely, but even better early, right? So we definitely want on time and on budget, or even again, better under budget. Of course, what that leads to then is our customers. We want happy customers. We want people to be happy who occupy these structures, during construction and throughout the lifetime of that project. So, but what can happen? You know, we all have some degree of risk, and everyone involved in construction is taking on some degree of risk, and that is the possibility of something bad or unpleasant will happen. So the two primary components of risk are the magnitude. Is it catastrophic, or is it something that just simply makes a bad day? And the other component is the probability of occurrence. So will this event, is it highly likely or unlikely? And that's how you measure your risk. So our challenge here is to reduce our risk. How can we make that happen with a construction project? So all projects are designed to meet some sort of expectations. Those expectations are generally defined in the project specifications. Sometimes it resides strictly in the architect's mind, and we have to become a mind reader to understand that, but that's another story altogether. It's impossible for one person to inspect and review and analyze every aspect of a construction project. So one person can inspect and review all the components, dozens if not hundreds of thousands of pieces and parts that take place on a project. And it's vital that procedures be in place that provide the assurance that those meet those expectations designed into the project. So how do we make that happen while we're reducing risk? Simple answer, a quality system, of course, a documented system of checks and balances, analysis, plans, revisions, and this whole cycle goes over and over again. And I don't know what happened to that graphic. So it's critically important to understand that both quality and safety are linked. Of course, we want our buildings to be designed and built to be safe. That's what the public relies on, design professionals and construction professionals to do. They rely on us to build these structures that are safe not only during construction, but during the lifetime of that project. So the answer here is quality assurance. Of course, quality assurance is the best way to ensure that what you build is what you expect. Sorry about the graphics, they're not exactly right. Anyway, so quality assurance and quality control are oftentimes used as terms that are interrelated, and sometimes they're switched around. So we'll clarify that here real quick. Quality assurance is an ongoing system to ensure that the buildings meet their design requirements. Quality control, then, is a part of the quality assurance process. It's really the daily activities that take place to check and measure and make sure that that quality assurance program is effectively being used. Taking things one step further, then, we can talk about certification or accreditation. Certification is a higher level aspect of quality assurance. It's essential to verify that the essential components of a quality assurance system are both present and functioning properly. It also provides the highest probability of a successful project with that third-party verification. So certification, people often think, oh, it's just someone coming in with their checklists and writing notes and just checking things off, and really it's much more than checklists. It's really the effective QA and certification programs are based on the industry's body of knowledge. And that body of knowledge is very important. The people in this room are part of the body of knowledge for the precast industry in China. Bodies of knowledge are generally developed by industry associations or institutes. So Precast Pre-Stressed Concrete Institute is an example of an organization that's developed the body of knowledge. And that's the collective knowledge of a group of stakeholders in an industry on how to design, how to build, the quality control aspects, certification, and so forth. So through those development of those bodies of knowledge, you can develop not only the design aspects for a project, but also the quality assurance aspects for production. So I mentioned PCI. They've developed the body of knowledge for quality assurance and plant certification and personnel certification and so forth. There's another organization, the International Accreditation Service. They do the certification and accreditation of various organizations. And also there is ABSIC. These are just examples. This is the Brazilian Association for Precast Concrete that's developed the body of knowledge in Brazil. So again, it's important to have one organization really centralize the organization of that body of knowledge. Talk a little bit about certification versus accreditation. So certification, again, is that program to check to ensure that the critical components of a quality assurance program are both functioning and present. can also be used as a tool for specifiers. So if I were an architect or an engineer and I were designing a precast concrete project, I would want to know that the precast concrete producers fabricating the project's components are doing so at some minimum level of quality. And in order to do that, you can specify the use of some sort of quality system, whether that be a quality, just an off-the-shelf quality system that you can use, one that you write yourself, ISO 9000, or one that a certification program that's already been developed, such as PCI. But it's a tool that you can pre-qualify producers for your projects, and that's an important aspect. So just because you may or may not work for a precast plant, as a designer, you have risk with those projects, and it's important for you as that designer to try and minimize your risks, and this is one good way to do it. So in this case, you see that the owners and specifiers can pre-qualify and select producers based on their qualifications that have already been determined and evaluated through the certification program. On the flip side, if you're a producer, what I have heard from precast concrete manufacturers is they like when they see projects that require certification. What does this mean for them? It means that all of the other plants that are going to be submitting bids for that project also have to subscribe to some minimum level of quality standards. So they all operate on a level playing field. Accreditation is, again, another step above certification in general. So accreditation is a formal, independent verification that a program or organization or institute meets established quality standards and is competent to carry out those specific conformity assessment tasks. So in this chart here, you see that the bottom layer, the bottom of the pyramid, is product and service providers. That would essentially mean the precast concrete manufacturers. Conformity assessment body could be PCI, could be NPCA, it could be the Precast Association of China, should they wish to start a certification program. And then accreditation is taking one step above, where an organization will verify that the conformity assessment body or the certification body is performing their certification activities appropriately and to international standards. So one important note is the accreditation process does not necessarily require the conformity assessment body, but if you take out the conformity assessment body, the middle tier, then you need to have technical experts insert themselves into that process. But the important thing here is the people on the bottom of this pyramid, the government, the consumers, the purchasers, they all want confidence, trust, and assurance that those projects that they're going to be, the bridges that they drive across, the buildings that they live in, they want them to be safe. So they're the industry stakeholders that this benefits. So accreditation could be looked at as a certifying organization certifying another certifying organization to verify that they follow international standards and best practices. So we talked about the body of knowledge a little bit. It's kind of a weird term, but it basically means that this is the collective knowledge of the industry. There's not one person that has the body of knowledge, and the body of knowledge isn't simply the books on the shelf that an organization publishes. It's everything that they do. It's all their activities, all their research and development, all those things that go into that collective knowledge. So that body of knowledge is used to develop building codes, design guides, education programs, and of course certification programs. But they're all essentially developed by people like you. Key elements of the development of a body of knowledge, of course, industry involvement. You've got to have a broad stakeholder aspect so that you have users, academics, designers, even general interest, just people off the street, public, if they have an interest, if they drive down the streets, then they have an interest in the safe operation and construction of projects. Of course, research is an important aspect where you can validate certain new ideas or new design concepts for engineering. In this case, there was a validation of blast resistance. So this is a precast concrete wall panel that's being subjected to a high blast force, that middle picture. And of course, we want to have that perform as we expect it to. And so we do that through research. Continuous maintenance, this is an important thing. You can't just take that body of knowledge and say, okay, we've got it. We don't need to maintain it anymore. It's good to go. You know, it's something that has to be continuously maintained. And that's, again, through organizations such as the concrete associations of various locations. One key thing to point out here, though, is that that body of knowledge, because everything comes from it, you should really only have one, in essence, because if you have multiple bodies of knowledge, it could cause confusion. Confusion on the building officials, confusion by the designers, confusion by people who are trying to apply the design concepts that are derived from that body of knowledge. So during design, of course, that's where everything starts to meet the paper. So design documents are critically important to the success of a project. Those designs should follow those building codes that are developed by that body of knowledge, and there should be a system in place to verify that those building codes are being followed correctly, calculations are being done appropriately, and verified. This all should be a documented quality system. Another important thing that I've seen is that we know these design documents are revised again and again and again. And so from the design office to the production floor of the precast plant, we want to be sure that the most current version of those design drawings are being used. So you have to have a process in place to ensure that those design documents are current, because as we all know, once you cast it in concrete, it's stuck that way pretty much. And then for the erection process, the documentation process continues with the development of an erection and stability plan to ensure the safe assembly of the structure. And then once you have the design process in place and you begin production, this is where the rubber meets the road as far as producing a quality project. So there's several key elements that are essential for establishing a good quality assurance process in a plant. First and foremost is your people. Your people in the plant are your most important asset, and they should be properly trained or certified when necessary. Another aspect is to make sure that your production demands do not overrule quality. So in essence, when we go into a plant and we look at their organizational chart and we look at how their personnel report back up to the management, we want to make sure that quality control personnel don't report to the production manager. We want to see that they report to top management or engineering, but they should not be in a situation where the client is demanding or the contractor is demanding product to be shipped to the job site, but there's a quality problem that needs to be addressed. The two should be separated, the quality should be addressed, and then shipped. You don't want that production demand to dictate what goes out the door and what gets shipped to a job site. And I've seen this also. So you want the quality assurance and quality control aspects within an organization to be accepted by everyone from the laborers all the way up to the president and top management of the company. Because quality assurance programs are not things that you can switch on and off from project to project. It has to be something that's integral in the culture of an organization. And I'm sorry to say, but I've been in some plants where it was obvious right away that the quality assurance program was not supported by top management. And there was a clear conflict between production and quality. So it has to come from the top, and it has to be drilled down because it's everyone's responsibility to do things right within the organization. It's not just one person. So as far as production practices are concerned, you should have a plant-specific quality management system that addresses certain aspects. So those production aspects are very important into the final quality, and those things include your production and curing facilities, welding. If you do welding within the plant, you have to ensure that you have quality processes in place. And also your forms and molds. Of course, those are very important to the final geometry of the products. Additionally, your hardware installation. In the United States, we have a saying that says, measure twice and cut once. So you always measure something twice before you do something where you cannot change it in the future. And the same thing is applicable to precast concrete. We call the rule of tens. So let's say you're in a production facility and there's a problem with the location of an embedded part, a lifting apparatus, let's say, or a connection. And if that connection that error is discovered in the plant at that time before the concrete is cast, it costs, let's say, $1 to fix. If you cast it and it's still in the wrong place, but it hasn't left the plant yet, now we're talking about $10 to fix, let's say. And if it gets shipped to the job site accidentally and that problem still exists, then it's going to be 10 times that, or 100 times what it would have cost to fix before you cast the concrete. So that's what we talk about when we talk about the rule of tens. It's always best to catch these things as early as possible. So the processes in place need to be clear to everyone within the plant. If they see a problem, they should stop production and fix it and make sure that those things don't get cast into concrete and have to be fixed later. Product identification, obviously, you have to track product through the process of production. You have to track it in the yard. You have to track it to the job site. You also have to track the quality control status, meaning whether or not that piece has been checked by quality control personnel. Does it need a repair? If so, is it marked to clearly show that it's not ready for shipment? So it has to be a process, a quality status that's apparent to everyone within the organization. Product handling. This is an interesting one because if you look at the design, structural design of many precast concrete products, it's designed for the worst case scenario and highest stresses. When does that occur? A lot of times. It's during very young age when the concrete hasn't reached ultimate strength and when it's being handled, lifted out of the form, stripped out of the forms, assembled onto the job. This is a very critical time for the condition of precast concrete. So you want to make sure you're handling and lifting precast concrete appropriately. And then surface finishes and appearance. So the structural engineers in the room want to ensure that we have a product that works structurally. The fact is the most complaints that I have received have to do with what it looks like. How does it appear? Does it meet the architect's expectations? Is there staining? Are there cracks? Is there mismatching between wall panels? These are important things to the designers, and we need to have a system in place to ensure that those surface finishes and appearance meet the owner or the designer's expectations. Of course, sometimes things happen and you have to repair a piece that either was dropped or there was a crack that formed or something happened. There was some honeycombing that unfortunately took place on a piece, so you have to repair it. But that's okay. We can repair it. We have things in place and processes in place that we can repair it. But you have to have a documented system for doing that. And you should be able to classify repairs as major and minor. Minor generally is something that's easy and is not structural, whereas a major repair would be something that's structural and needs to be evaluated by the plant engineer. So those processes, again, need to be documented. Now, raw materials and accessories are all these things that the plant receives from another person, another third party. So you're relying on them to supply something that at some minimum standard. But it's still up to the plant to ensure that what's coming into their organization meets their specifications. So you have to have a process for all the concrete raw materials, verifying through chemical analysis, mill test reports, other documentation that it meets the specifications. And of course, reinforcement and hardware. Reinforcement is the key for our structural capacity. The concrete itself, mixed proportioning is an important aspect of producing precast concrete components. Most plants that I've been to have their own batching and mixing operation, so this is something that they would directly be involved in. So mixed proportioning is an important aspect. Storage and handling of those raw materials, making sure that there's no contamination, that they're handled correctly, that coarse aggregate does not segregate. Your batch plant the scale should be calibrated. The whole thing should be getting what you expect. So when you batch a load of concrete, it should be giving you the weights of the materials that you're expecting. And transporting equipment is also important because you can have a very good mix, but yet you use the wrong transportation equipment and your mix can settle, it can segregate, and so on. Placing and handling equipment are important. Each operation will have a little bit different way of doing things, so those specific ways of producing precast concrete should be addressed in the plant quality system manual. We talked about batching and mixing and transporting, very important aspects. Consolidating concrete. More and more we're seeing self-consolidating concrete, so this hasn't been as much of an issue, at least in North America. I don't know how much self-consolidating concrete is used in China, but certainly it's been helpful in the United States because it's eliminated a lot of problems with consolidating, honeycombing, and things like that. Surface appearance looks very, very good. And curing. Of course, curing can have a substantial impact on the long-term durability of your concrete. Reinforcing and pre-stressing. The placement of the reinforcing steel is very critical, as well as the tensioning operations, whether it's pre-tensioning or post-tensioning. You have to have proper checks, QC checks, for verifying elongation, the proper force in those tendons. Quality control operations, these guys are always very busy. So they're busy inspecting and testing various raw materials, concrete, pre-pour and post-pour inspections. And they're also doing a lot of record keeping. And unfortunately, record keeping is something that is necessary for quality control. Oftentimes neglected, but very, very important, especially when you want to prove to someone that you've followed proper procedures. If something happens later on, there's some sort of damage or collapse, you want to make sure that you have information in your files to prove that you did what you say you did correctly. Most plants will have laboratory and testing facilities on site. If they don't, then they will outsource that and have someone else do the testing for them. And product tolerances. The tolerances are very important because you not only have to put the building up and have it be plumb and have pieces fit together correctly, but you also have to deal with your interfacing tolerances between different materials. Your windows will have different tolerances as well as other materials that are being used in the building or project. So as I mentioned, all of these things should be addressed in a plant-specific, written for that location in their quality management system. You can't just take a quality management system manual from another organization and put your name on the top and say, okay, we have our quality management system, because it's very specific to that operation and that location. That quality manual should be reviewed at least annually, if not more, or whenever necessary, and that should be done with top management involved, not just the quality people. They should also perform annual internal audits. Those internal audits should be done by someone who is not directly responsible for the work that they're auditing. So I shouldn't be auditing my own work. If that's the case and I'm doing an internal audit, I need to ask someone else to do the audit for me. And copies of those manuals should be readily available throughout the production plant so people can easily access it. Whenever changes are made, then those manuals should be replaced, and make sure that everyone has a copy of the current manual. I've seen that. So we've done all this work in the plant, we've done all this work to be careful about the design, and then we go to the job site, and we need to make sure that same careful attention is also taken to the project site. Proper erection is vital to the performance of the safety of the structure. I can't say this enough. It was at one point in time there was a major collapse, and that was the reason why the PCI erector certification program came into existence, because there was an issue that took place. So we want to make sure that not only does the precaster follow a quality assurance program, but the installer or the erector follows a quality assurance program as well. So that program really focuses on safety. There's a lot of safety that goes into the erection procedures. The erection and safety plan should be specific to that project. They have to address specific fall hazards and protection issues. You talk about the scope of the safety practices and of erection and patching, because we know that patching sometimes takes place on the job site after it's been installed, so we have to do that safely. You should define your safety monitor duties. That's the person who's in charge of safety on the job site. And talk about the type of job site safety practices that will be employed. Daily job site checklist for erection safety. All these should be documented. You should have a drawing that shows where the crane will be located, where the trucks drive in and unload the product, access roads. Should have some sort of documentation about sequencing of erection and bracing plans, and a list of emergency contacts. If an emergency should happen, you should be able to get in contact with emergency people right away. So you need to review the rigging and bracing requirements, now, this is an interesting one. The adequacy of the foundation is very important. This may not be something that a precaster is directly in charge of, but they're going to be setting their pieces on that foundation. And we had a problem with a foundation many years ago, and that's where that collapse occurred. And that's why we now have something in our erection procedures that specifically addresses foundation adequacy. Structural stability is important because, of course, the structure is not complete, and so you have stability issues until all the pieces are in place. So you need to be applicable, again, with those tolerances. Inspection of equipment is also important, your cranes, your rigging equipment. Of course, we talk about our people again. You need to have trained and certified welders. There is quite a bit of welding that takes place on projects in the United States. Grout testing is also important. We had another problem with grout not too long ago. So these are little things that if you don't pay attention to them, can become very big problems later on. And piece handling, again, these pieces may not have reached their ultimate strength, and so you could be subjecting them to high stresses, and so you want to make sure that it's done appropriately. So quality assurance is essential. Looking at the programs that were developed in the United States, 1950s, pre-stressed concrete was an unproven technology, and the development of PCI, they developed their body of knowledge, the certification program, and the design documents at the same time, and they did that to provide legitimacy to the pre-stressed concrete technology. If it weren't for that, it may not be as successful as it is today. Today, the certification and accreditation programs play a little bit different role. Because pieces are fabricated off-site, job site inspectors don't have the ability to observe and inspect products that are being fabricated in a factory. So we have to provide that assurance that it's being fabricated correctly. The certification programs are also a tool for owners and specifiers to pre-qualify producers. So, certification programs have played a critical role, and quality assurance programs have played a critical role and will continue to play a critical role in the success of the precast and pre-stressed concrete industry. Not only through the development of the technology and the proof of technology, but also as we want to ensure that structures are safe now and in the future. And again, I'm confident when I say that the precast and pre-stressed concrete industry would not be as successful today, at least in the United States, if it weren't for the certification program and quality assurance programs that PCI developed. And that is my conclusion. Thank you.
Thank you, Dean. Thank you, Dean. Listening to your presentation, it brings me to a question in Germany and also in some other countries. I mean, in reality, it's sometimes the case that it is very expensive to reach 100% of perfection immediately during production. That means the producers accept that they produce maybe 95% of perfection and then do some cosmetics afterwards. How would that fit into a quality assurance system?
Well, we go back to what I said before, is you have to manage the expectations. So in this case, and that happens a lot, and you know this, the people, the designers, the architects, they have to understand that there might be some of those types of fixes that take place on the job site. And if they have that system documented in their program, it's okay. But that's when I get those phone calls from people saying, hey, this doesn't look the way I was expecting. And you say, well, is the producer going to fix it? Did you ask? Oh, maybe I should ask that. Of course the producer has a plan to fix it. So it's all that management of expectations. I think that's an important aspect.
Okay, maybe last question. How long would it take for a precast plant to set up such a QA program? Let's take an average plant with a size of maybe 200 people.
From scratch?
Well,
several months.
If
not up to a year.
Yeah, okay.
It really depends on how prepared they are. That's been my standard. 2 to 4 months if someone is ready. You know, they kind of have a quality system in place. And the thing is, when you get audited, you have to have proof. You have to have some documents in place that you show that you're following your quality manual. So that takes time. It does take time.
Well, okay, thank you, Dean. Any questions to Dean from the audience? If this is not, it is the case from our Belgian friend.
Are you allowed to lower your safety coefficients if you have a quality system?
Currently, no. In the there's nothing codified that I'm aware of that would allow the reduction of any sort of load or resistance factors or whatever. Precast in and of itself is given a little bit of leeway when it comes to that because they know that precast concrete is manufactured in a quality controlled environment. So there's certain things, the amount of concrete cover required in the building codes is less for precast concrete because they know they're going to get a higher probability of it being in the right spot. But as far as the design coefficients and so forth, I'm not aware of anything that addresses that. But that's a good idea.